Hi everyone, my name is Gideon Besaidnat and I am an application engineer for Micrographics. Today we're going to have a look at Autodesk Inventor and how we can utilize the motion rotation and translational constraints within the assembly environment, and how we can use the drive function to drive a normal constraint to create that smooth motion. When it comes to the assembly environment, most of you should know by now that you can assemble parts using joints with the rigid, rotational and slider or cylindrical joints, and in the constraint environment, creating your normal constraints with mates, flush, and your angle, tangent, and insert constraints as a few examples. Now, when it comes to using the motion and transitional constraints, you still need to have your normal constraints. And one very important thing to remember is you can't drive a motion or transitional constraint. You can only drive your normal flush or angle or insert constraints in the assembly environment. The motion and transitional constraints are quite beneficial for you to create that smooth motion within an assembly. I've got a normal small assembly open here, and you will notice that I do have constraints, but my assembly it's not fully constrained. The reason why, I still need certain parts to be able to move in a specific motion, in a specific action like the rotation or backwards and forwards. When you create your assembly, it's quite important to understand the relationship of constraints that's being set. In the assembly tab, productivity panel, you can click on the drop down to find your degrees of freedom analysis. Now this will inform you about the degrees of freedom that is left within your assembly. Now when I talk about driving a constraint is, for instance, if I go to this specific mate constraint over here, you can right click on it and create a driving motion to create a nice smooth motion in your assembly. Now we're going to have a small introduction on how we can utilize the motion and translation constraints. First, I'm going to go into the constraints, choose a transitional constraint. Going to ensure that I'm selecting the round radius of the cam and the round cylinder of my part, and say OK. I'm pressing OK to finish the command, that I can still show you the movement that is allowed within the part. As you can see, my cam cannot move all the way around. It almost created like a smooth transitional constraint between the round cylinder and the cam. From here, I'm going to choose rotation translation constraint. I'm going to ensure that I'm getting a smooth reverse motion. Quite important to select the pin first and then the edge. Going to say apply, switching to the rotation motion, going to select the center line of the second pin, then the first pin, also in a reverse motion, and let's say I want the ratio to be 3. Now, because of that motion that has been created, the ratio would be 3 to 1 for the movement speed. Again, going to choose a rotation translation constraint, ensure it's in reverse, select my pin first and then my edge. Going to say apply, and lastly I'm going to choose a transitional constraint again on this cam and the round cylinder and say apply. Now you can see there's a movement happening when this is constrained and created with the motion and transitional and translational constraints, but my part is not fully constrained yet. Now from here it's quite easy. I can simply go and choose an angle constraint. Going to choose this lever, going to constrain the YZ plane to the base origins YZ plane. Going to ensure it's on a direct angle of 0 degrees. And now we've got a fully constrained assembly, and this is what we are looking for when we want to create a nice smooth motion and drive specific constraints. In the cam part where I've just created that angle constraint, again you cannot drive motion constraints. You can drive normal constraints. Now in this instance I want to drive the angle. The reason why, I want this to be able to move at a specific angle and then allow for this part to move back and forth and have the continuous movement between all the different parts. Going to right click on it and say drive. Now in this instance, this sometimes, depending on your assembly, will have a certain play functionality for you that you need to trial and error, and I will not be able to go and say okay, this cam needs to be able to start at 90 and end at 90 degrees. If I say play, it's not going to allow for that motion because of the specific parameters and the diameter of this radius, because it can only turn a specific amount. Because a translational constraint have been formed and the movement can only allow while this radius touches that cylinder. Now I'm going to ensure that starts at minus 24, it ends at 24 degrees. I'm going to change the total steps. I'm going to make that 100 for an instance. The repetitions, it needs to go to the start, then the end position, again end at the start position. And for instance I want 8 repetitions. Just going to go into my home position. Now if I press play, you'll see the nice smooth motion that has been created, and this drive of that specific angle constraint allows for the rotation motion and transitional constraints to take place, and it would take 100 steps, incremental steps, and it would the 8 repetitions to take place for the motion to stop. Again, if you look at the movement speed of the first one and the second one, it's quite slower. The reason why, it's because the cylinder was set to a 3:1 ratio for movement speed. Thank you guys for watching. Please like and subscribe and follow for more.